Welcome to the 2023 Big Idea Challenge question and answer sessions. My name is Stacy Dees, and I'm the program manager for the Big Idea Challenge, and I am very, very, very excited to have every single one of you participate in this call. We had our NOI submission deadline, as many of you know, and just had some really interesting and exciting concepts that were proposed. And so we're very much looking forward to seeing those full proposals and hope that we can clear up any questions that you might have today. And we'll talk about a mechanism later on in the webinar today about how you can ask questions in the future, but hopefully we'll get you straight as much as we can today. So Robin, if you would go ahead and click to the next slide. As she's doing that, I'd like to let everybody know that we are recording this session, and it's our intention to post it on the FAQs page so that if you missed something or want to go back and listen to it again, you can. And we will also post a PDF transcript of all of the questions and answers so that you can kind of search through them by doing keyword searches if you'd like to do it that way moving forward in the future too. So give us about a week after the session and all of that information will be posted there for you. We do ask that you would mute your microphone as we move forward so we can make sure that all of the speakers are heard. And here's kind of a brief look on your screen of the agenda and the flow for today's Q&A session. We'll start out with a quick welcome and introduction of some of the players on the call, and then kind of turn that over to our chairs to talk about the context behind the challenge and to talk about a few kind of general technical remarks of common themed questions that came up in the questions that were submitted in advance that I think will help clarify a lot of responses for you all. And then we'll kind of open it up to some additional questions if there's time permitting, and I think there should be time permitting given that we have an hour and a half today. At that point, we'll kind of go through the instructions for asking your questions. So you have the ability to drop those into the chat then, and we can read them out loud for you. Or if you want to raise your hand, we'll call on you one at a time. You can click your mic back on and we'll let you ask your question. Then we'll just wrap up with a few kind of programmatic reminders and get you guys out of here today. Moving on to the next slide, this is just a quick peek at some of our team. There's our boss, Shelly Spears, myself, Stacy Dees, Robin Ford, and Janice Miller, who are both on the call with us today. And at any point in time between now and your proposal submission, you could be receiving emails from any one of us. So we wanted to make sure that you knew who we were and recognized our names in case if you got some emails that came in. But we try to keep you updated and send out as many programmatic reminders as we can and are always there to answer your questions. Make sure that you have what you need to submit really amazing proposals to us. On the next slide, we're going to see the panel of judges, and we have a superstar panel of judges. With us today is Karen Taminger and Kevin Kempton. They are our co-chairs. Karen is from NASA Langley, as well as Kevin. And then we also have some other judges that are listed here. I encourage you to visit the website on the About Us page, or there may actually be a separate judges page. We've got information and bios on each of our judges to kind of show you their specific areas of expertise as it relates to this Lunar Forge theme. And it's just an amazing variety of expertise and history and wealth of experience in a lot of different aspects of this particular theme. So we're incredibly pleased to have them as a part of our panel this year. Now, I do want to just put in a quick comment that everybody understands that because these judges are the judges for the competition, you cannot reach out directly to them and ask questions. That would be a direct conflict of interest for them to help and support you. So if you do have any questions for the challenge, what we're going to do is ask you to send them to the Big Idea email address. And my team will make sure that we get the technical answers from you from the appropriate judge. We'll respond back to you with those answers, and we will post them on our FAQs page. And the reason we do that is because we want to make sure that all teams have access to the same information. They're not getting any preferential treatment or information. It's just a very even and fair playing field for anybody who is proposing. So please do not reach out to these folks directly. If you are selected as finalists, you'll get the opportunity to work and connect with them a little bit more at that point. But for right now, please refrain from reaching out to them. Except for today, of course, you can ask Karen and Kevin any questions that you want to. So let's go ahead and flip to the next slide. And I'm going to turn the microphone over now to Kevin Kempton to talk to you a little bit about the reason NASA is investing in this theme and kind of what we're looking for and things to avoid. Kevin.
Yeah, good to meet everybody. And this is a different challenge from what you guys are used to in your college classes. We're going to be looking at you to be basically principal investigators. You'll be proposing a project. You'll have to justify that project, and then you'll have to implement that project. So there's a lot of project management, systems engineering, as well as the technical expertise that you'll have to show on this. And this is a real project. Just like I work in the Game Changing Technology Development Program Office, and we take technologies out of the lab, we test them so they're ready for the space in relevant environments, so they're ready for space flight. You'll be getting real money. $180,000 is up to is a lot that you can do at the university level on development. A lot of that will be buying components. Renting test facilities and paying some stipends and a little bit of travel money. But it's a real project, just like we have in GCD. Um, a lot of things we ask about what you're going to build. We're looking at the moon around 2035 is a good time frame. If you look at the Artemis, the NASA Artemis plan right now, we're looking at ramping up the Artemis missions up through 2031, when we'll have 4 people for 30-day stays on the lunar surface. After that, we're going to be trying to go for full-time habitation. And so you guys are looking at what's a lunar base going to need as far as metal products. On the lunar surface, of course, you're going to want pressure vessels. We want to extract water. We want to extract oxygen for rocket fuel. And taking a pressure vessel up to the lunar, placing it on the lunar surface is really, really expensive. So if we can build these things on site, then we can be much more cost effective. When you have pressure vessels, of course, you'll need pipes, you'll need structural materials, you'll need landing pads. Metal is a great surface for a landing pad to keep all the debris from getting blown away from the rocket plumes. And so there's a lot of things that you can build with metal. And what you're looking at is it's a wide open challenge. You probably don't get this. Usually you get a lot of constraints on the problems that you get in class, but now this is you've got to propose something that's valuable to NASA that we want to have, in the 2030, past 2031. We want to have this type of things on the lunar surface so that we can be more cost effective and we can do more with less. And so you've got to make that pitch. And like I said, I wanted to add real quick the exclusions, why we're doing these exclusions on the drilling, excavation, and transportation. The main reason is we have a list of challenges about as long as my arm that we've done on excavation and transportation, but the metal production pipeline is a little bit beyond that, but we haven't had any challenges on that as far as I'm aware. And so this is a new start for the teams to start thinking about things that are going to be needed, but we haven't done a lot of work on it. And I encourage you to go look. There's a link in the references on some of the ISRU things. They're really starting to think about metals for exploration and what we'll need on the lunar surface. And so they start talking about this. And so that's all I have on that, Stacy, if you want to. And so again, this is an open innovation competition. You're not used to it. And so there's not a lot of constraints, but we want the teams to come forward, do the research. You're going to have to justify why you make assumptions. You're going to have to assume what power levels you can use. You'll have to assume your mass. I mean, there's things like launch vehicle volume envelopes and launch vehicle payload mass limits, and then you'll look at things like you know, there's a lot of CLPS landers out there that have specifications on how much they can get to the surface. Now, a lot of that's going to change in the time frame from, you know, from now to 2031, but make assumptions and try to make them reasonable. And the same thing with assumptions on the amount of ore concentrations in the lunar regolith. Is any proposal, you want to be optimistic, but you also want to be realistic. So you're on that razor's edge on that proposal. So that's your toughest choice, is how to make it compelling yet realistic. And so we'll call it optimistic, I think. It sounds like Mary Poppins, a new term on your proposals. But just developing proposals is a skill that's so important if you want to be successful at NASA and in business. And proposal development, like I said, you're going to learn a whole lot about it as you go through. Teams should not be. I wanted to add, I think Stacy put this in there. I wanted to add, you don't have to stick with the NASA strategies, because right now they're still evolving. Look out on the web and find concepts for lunar bases and things like that. Because like I said, once we get to 2031, we're really hoping commercial industry, private industry steps forward and starts building things, and then you get this industry going on the lunar surface. So you don't have to go 2031. You know, pick your time frame, come up with a compelling idea. The development of space systems takes a long time. If you look at the Webb Space Telescope, that's been in development for, 10, 12 years. The same thing with the Space Launch System. It takes a long time to develop these space systems. And so, the time frame that we're talking about, 2035, where we have actual metal production on the moon, to you, it seems like an exceedingly long time, but really in a space environment for developing these type of systems and testing them and getting them on the surface, it's probably realistic for a metal production facility. And then you talk about scoping a project. The thing is, the scope of your project, it has to be achieved within the time frame and the resources for the Big Idea Challenge. You know when the forum is, and so we've got that midpoint review that you have to have almost all your stuff in place, and then you have to build and test it in the next phase. And then you also have your resources. Like I said, the maximum is $180,000. Do not feel like you have to spend $180,000 if you can do something smaller for less expensive. We are looking for value. If we can have two projects at 90,000 instead of one project, one lesser project at $180,000, we're doing it by value. So we want to include as many teams as possible. And so one of the things I wanted to add, to scope your project, if you look at the guidelines, we've got all kinds of things in there about project management. You develop your milestones, you develop your schedules, you have your budget. And so you've got to be realistic on that, or, the judges will say, this isn't realistic. They're not going to be able to finish this unless they de-scope their project. But again, you've got to be optimistic as well as realistic, because if you're not optimistic, you're not really going to have your proposal might not be real compelling. So it's a fine line you got to do, and doing that, it's going to be one of your toughest decisions on scoping your project. And then the mission starting point, like I said, make a reasonable assumption. We're not looking for 2031. It could be 2040, but whatever it is, it should be something that supports developing a lunar infrastructure, a permanent presence on the lunar surface. And we're looking for return on investment and things like that. You've got to be able to sell this, the value of doing it. It may be a demo system, like we had with the MOXIE. I think there's another question that we talked about, and I'll cover that. But yeah, that, like I said, hopefully that'll help.
And I just want to tack on a little bit to something that you said, Kevin, about the proposed budgets. We really, truly are looking to fund some smaller value projects, as well as some that are on the higher end, between that 50K and the 180K. So that is something that we are actually physically and intentionally seeking to do. So please do, if you've got an idea that you don't think will cost that much, and because the scope of it is small, we're still looking for that. So I just wanted to really, really be clear on that. And before we jump into the technical questions that we received in advance, Karen, do you have anything to add to what Kevin said in terms of what we might be looking for?
When I think about going to the moon, I think back in history to what Christopher Columbus brought with him, what the colonists came to America with. And so, really, use that history, that look back in history. We are looking to bring some tools to help us do all of the things that we need to do on the moon. So I don't know if that's helpful or not, but to me, it helps kind of give a frame of reference as to what we're looking for here. And so have fun with it.
Perfect. That's the most important. All right, well, let's jump into some of the questions we received in advance. I will give you a forewarning that the first couple ones have kind of already been addressed, but we're just going to move through them anyways, just in case somebody missed something. And I'll go ahead and read the question out loud, and then Kevin or Karen, whoever wants to jump in and respond, you're welcome to. So the first question says, what exactly are we making? Machinery to make the metals or the metals themselves? And a similar question, are we making the actual power cables or pressure vessels, or are we trying to manufacture the metals?
I'll just add the short answer, just about anything that will help us obtain a permanent presence on the moon. And so look at your use cases. I think that's a big theme in what we're doing. Your use case is your Shark Tank pitch. We talked about the Shark Tank. You're making a pitch. And so your use case sort of describes what you're going to be doing. And then you've got to break that problem down and pick one of the technologies on that overall use case and advance the TRL, the technology readiness level. And to advance the technology readiness level, it means higher and higher fidelity testing and higher fidelity design. So you could be advancing from out of the lab just to get it working, in an Earth-based environment. That's sort of a TRL, 3 to 4. Or you could be advancing it and testing it in a very realistic environment in a thermal vac chamber. That would be sort of from the 4 to 5 or 5 to 6, because you fully tested it in a relevant environment. So pick one part of that or more parts. And so the more you can advance the technology readiness level of the system of interest, the better value it will be. And one of the things I wanted to add on your use case, if you've got a technology that you want to try out and you can't get a compelling use case for operation on the lunar surface, it may be a great technology, but your technology doesn't match the problem. So make sure you can come up with a compelling use case and make sure the technology that you want to develop is something that's really important to that use case. So hopefully that helps. Karen, you want to add anything?
I think we've got a lot of questions, so I think that's a good summary.
You get to choose which part. That's the shortest answer.
Exactly.
Second question, are we assuming that we already have the needed materials on the moon? And similarly, what machinery are we assuming would be available on the moon for our proposal to be hypothetically constructed? Is this an assumption that we must make?
Yeah, we're just asking you to make reasonable assumptions. If your assumptions are overly, are kludge just to fit something, or they're like alchemy, then the judges aren't going to think you're credible. But do your research, do your assumption. There's so much material on lunar ore, mineral concentrations, metal extraction. Just do your research, and if you have questions, I mean, you can't ask the judges directly, but you can send questions into the NIA, or you can find subject matter experts that'll help you. Hopefully, a lot of your professors have some knowledge in this on your assumptions and the minerals on the moon. I think if you go look in the references on the Big Idea Challenge, there's a lot of links for reference material, but that's by no means all comprehensive. There's so much information on it. Like I said, just make sure it's reasonable.
All right,
And
next
to add
question.
on to that, if you've got assumptions, state them. Explain what are you assuming you have? You know, if you can assume that there's power available. And so, you know, if you are assuming you've got power or communications, or you need some robotic capability to be able to make what you're trying to do work, state what those assumptions are. What are you expecting to already be there? It doesn't have to be something that we know will be there, but just help the judges out and say, you know, well, we assume that there will be a power plant that can provide the amount of power that we're going to need to to execute the project that we've got, to execute these experiments and to build these parts.
Yeah, I just wanted to add on. I talk about system of interest. The system of interest, basically, it's bounding your problem. If it's downstream from the technology that you're trying to demonstrate, then it's somebody else's problem, and all you have is an interface to it. So you're receiving something from downstream, you're producing something and sending it upstream, to be further manufactured. And upstream is probably not your problem either. So bound your problem and make clear assumptions on where your system of interest starts and where your system of interest ends, and what it needs and what it produces. And so if you can do that and bound your problem, it'll make your life a lot easier. And that boundary is where you make the assumptions.
We all love boundaries. All right, next question. Are we required to focus on one part of the metal production life cycle, or can we propose a project which encapsulates the entire metal infrastructure production life cycle for a particular product or class of products?
Well, I'll say, real quick, this runs on to a lot of the things that we talked about before on your system of interest, and defining at a high level, defining that overall production pipeline, and then you can add the details into your specific system of interest. But make sure that the high level makes some kind of sense, that it sounds reasonable. You don't have to justify everything, but just make sure it sounds like, yeah, this is pretty reasonable. And there's, like I said, a lot of material that you can look up, and a lot of subject matter experts to talk to.
And I think, to help you with framing, to narrow down the scope of what you're trying to build. Manufacturing can build many, many things. The capability that you are going to develop to show that you can produce metallic parts can have many outcomes. Pick one and focus on one that you can explain how this is important to operations on the moon. And so don't get bogged down with trying to say, well, I can build this piece and this piece and that piece and 6 other pieces. Focus on one and build a story around that. So build a scenario and explain, this is how I can build this part and why that part is important for me to be able to build on the moon.
Okay, and then in terms of demonstrations, do we have to demonstrate our technology throughout its entire life cycle, including fabrication, operation, disposal in the future?
Yeah, the answer here, no, not the entire life cycle, but you need to think about it. A good system engineer is going to understand the life cycle, from fabrication to disposal, because a lot of the design decisions are influenced by that life cycle. If you can't fabricate it, you might have a great design, but it's not going to be a very good design. One of the things is the testing. Like I said, this is such a big deal for the game-changing development projects. It's verifying relevant environments, that you can operate in relevant environments. So early on, it's going to be a big part of your effort and cost is to verify whatever you want to demonstrate. If you want to verify it, like the temperature extremes, you got to really think about your test environment before you do it. If you want to verify that you can do it in a vacuum, that's going to require a pretty major facility. You can't do that unless you have some type of vacuum chamber, which is not hard to come by, but they can be expensive. Or if you don't, or you could get it get them loaned to you. NASA provides universities, that kind of stuff. But you've got to do this well in advance. And so you've got to start getting it on the schedule, because some of these facilities, they have a big, a lot of customers. And so if you try to do that at the last minute, you're not going to do it. And plus there may be costs associated. You may need to get some type of formal agreement. So you need to think about what type of testing that you're doing early on, because just showing it working in the Earth environment may not be that TRL advancement that's going to be a compelling thing. You've got to show something along the space environment that should be so that it can operate in. I hope I got that right. Okay. You got anything, Karen?
Yeah, when we talk about a relevant environment, what we mean by that is what the location on the moon is going to experience, right? The temperature extremes, the light, the darkness, the vacuum. But you don't necessarily have to, if you can show that the experiments or the processes that you're developing are not sensitive to gravity, for example, then it's not, explain that. I can weld overhead. Surface tension holds my weld bead in place. If I can weld overhead, then I can handle something in a reduced gravity environment. And so you don't necessarily have to replicate the full environment if it's not important, if it doesn't have an impact on the processes that you're trying to do. So just keep that in mind too, for, don't overcomplicate it if it's not important to the outcome that you're going to get from your experiments.
Yeah.
Good reminder.
I was just going to add real quick on the things like in the space are non-intuitive for, here on Earth. And like the thermal management is, you can't have, convection and things like that in a vacuum environment. Your heat has to be either conducted or radiated away. And so, think about, you guys will be working, if you're working with metal, maybe some high temperature stuff, and you've really got to think about thermal management, and being able to just simply test the thermal management could be, a big part of your project, because it's very hard to do. And the lunar surface has much higher temperature extremes than we find anywhere on Earth. You'll get hotter, and you'll get much colder in some of these environments, especially near the lunar poles. And so think about that.
All right. We do have just a few more questions that kind of segue into some of the things that we've already talked about, and then we get into a brand new area of discussion. But for number 5, do we show a single point of the process being doable with the rest of the process being given?
Yeah, I just said we've talked about that a lot in your system of interest. And if you can pick one small part of that production line that's going to really help us, we've got this thing. If you solve one problem that we need later on, that's something that we can take forward and build the other parts of that pipeline. So anything you do is going to have value later on if it's relevant to metal production on the lunar surface. And so even if it's a very small piece of that process, it's going to have value to it. And the harder it is to do, the more value it's going to have.
The next question is very similar. How much of the process do we actually have to design for? For example, just the roads, but not the sidewalks?
And again, like I said, it depends on your end product. And the end product could be anything along that pipeline. Like I said, metal ingots could be your end product, or even refined ore at the basic level. Your end product, we talked about prospecting. Your end product could actually be at the lowest level, being able to prospect for concentrations of lunar ore, because that's a real challenge. Because the lunar surface, like I said, has been mixed, by all these meteorites over billions of years, and so the concentration method, are much different than they are on Earth. Like I said, ingots could be your final product. Metal plates made from the ingots could be your final product, or even a landing pad made from metal plates could be your final product. So you may want to concentrate on something like um, removing impurities from metal. That could be the technology that you're showing. As long as you can do it, as long as it's applicable to a lunar environment. And like I said, I wanted to add real quick on the lunar environment. If your process needs to be in a pressurized workspace, that's okay. But remember, it adds cost to do that inside a pressurized workspace. And so there's a whole gamut of things that you could do. And I can't just answer in a single say yes, no type answer.
And I want to just mention that the reason that NASA got incredibly excited about this particular theme, in large part because it provides such a variety of options for people to participate. It's not them telling you what to do, it's them saying, hey, here's this whole process, this whole pipeline, pick something along that and give us something useful out of it. So that opens up the doors to such a wide variety of expertise, of interest levels, capabilities at the different universities. And really, we're looking for such a wide variety. We're not giving you very prescriptive things of what we want. We're letting you tell us what would be valuable along that pipeline and how would you demonstrate to us that you can do it. So that's kind of the basic answer for a lot of these questions. And it looked like, Karen, that you were going to jump in and comment on
Yes.
that as well.
Yeah, the other thing is use your creativity, use your, we're looking for innovative solutions. And so additive manufacturing is it's in a lot of places right now. But what are you going to do with that additive if that's the direction you go, right? What are you going to do with the additive manufacturing? It's less exciting to us if you're just going to program a commercial system and build something with it. What is the twist? What's the innovation that you're bringing to this beyond what's commercially available? So think outside of the box.
Always outside of the box for the Big Idea Challenge. All right, the next question. Do you want our machines to extrude metal or another type of material?
Yeah, like I said, extrusion is just one process for producing metal. You could extrude pipes, structural members, wire. I mean, those are all big things. But remember, that's not the only thing. There's questions later on about metal powder. Metal powder is a key feedstock for additive manufacturing. It's selective laser melting, and so it doesn't have to be extrusion, but and I have another question on another type of material. You can mix materials. There's things called metal matrix composites, and especially even on the lunar surface, you might get regolith and heat it up such that the metal becomes a matrix on that regolith. That would be a good landing pad material. And so and also it's a great structural material if you can figure out how to do that. And you could heat it up with microwaves and melt the metal that's in the that's placed into regolith, and you might have powder in there, heat it up, and have a metal matrix composite. So there's a lot of things you can do besides extrusion. But realistically, I wanted to mention on the extrusion, you look at some of these the Big Idea Challenge visual that we have has this big pipe coming out. I don't think you guys will be able to do that, but maybe extruding wire. Wire is Karen will tell you wire is just a key feedstock if you're using electron beam freeform fabrication, where you take a wire and then you melt it with a electron beam, and it works great in vacuum. And so yeah, on Earth, the way we do it, we have to put it in a very low pressure environment. But on the lunar surface, you've got that beautiful environment that's very friendly to electron beam preform fabrication. So there's a lot of things you can do on this, and maybe Karen will have more ideas.
And it doesn't just have to be electron beams, right? It could be an arc, it could be a laser, but also keeping in mind that, you know, because you're working in a vacuum, what does it take to transfer that heat to get to your product for processing? You know, so this question specifically asking about metal or another type of material. Metal is the heart of this. So we would expect to see metal as at least part of the solution, but it doesn't have to be the only one. And certainly there are lots of reasons and lots of applications that require a whole variety of materials, but that's what we're targeting here.
And Karen reminded me of one thing. I talked about the exclusions on mobility and excavation. If you want to do a demonstration, you can certainly have a scoop and you can certainly have wheels on it. That's not excluded, but we don't want you to focus on a mobility, you know, an overall mobility solution or an overall excavation system. So I just wanted to reinforce that mobility in excavation and things like in drilling are not, you know, can be a supporting part of your demonstration, but it should not be the focus on your demonstration. I just wanted to add that in.
Okay, and then the next question is related to constraints and wondering how much ferrous metal is required to be extracted or processed by teams.
Yeah, this again is it's open, but I wanted to add that, you know, you could develop something that might be an early metal production demonstration system. And so think about the MOXIE experiment that's on the what is it, the Perseverance rover. They developed this at JPL, and it's a box about the size of a toaster, and it actually compresses the CO2 and then runs it through a solid oxide system that breaks the CO2 apart into oxygen and carbon monoxide, and they take the oxygen and then they store it. And so the cool thing is they've done that. Just, you know, they came out with a recent report on that, and so they've done that now and they've tested it, and so now it is a TRL6 level of actually, you know, TRL7 is operating in space, so you could call it 6 or 7. And so we know this technology works, and if we want to build it later, we can just, you know, we think we can scale it up to produce oxidizer for rocket fuel, so we can get off Mars based on the atmosphere, you know, just using stuff from the atmosphere. And so that's a big step. Now, if you guys want to show something, you know, landing on Eclipse lander in like a 2030, 2028 timeframe, that's going to test one part of your metal production pipeline, a demo system is just fine. So you don't need to have some type of amount, you know, for that one. Just showing that you can do it in a small amount is all that's needed. And so you might want to use that as your use case, that you're going to send a demonstration system on Eclipse lander, and you're going to grab some regolith, and you're going to show that you can purify that regolith and extract, you know, high quality ore. That might be your use case. So, and it still would be valuable.
And there are a number of different metals found in various concentrations on the moon. And just like on the Earth, there are richer deposits in some areas than others. And there are reports that you can look up to give you an idea. So take a look at the composition of the regolith in general, and composition in certain locations, because those locations may dictate the relevant environment, you know, the thermal and the light environment, as we talked about earlier. But this question is asking about ferrous metal. It doesn't have to be ferrous. It could be aluminum, it could be titanium. It just needs to, you know, do your homework on what is available in the regolith and how are you going to extract that? How are you going to take advantage of what materials are available?
And as we move forward with the questions, I'm going to ask Karen and Kevin to be just a tad more concise in the responses to make sure we get through all of them. So number 9, is it fair to assume?
Yeah, we always run short of time, but we have to give time for Stacy. Yeah, the metal powder, like I said, there's all kinds of challenges for developing metal powder, but there's also all kinds of opportunities on the lunar surface for developing metal powder. Metal powder is a great feedstock. So if you can show that you can make metal powder in a lunar environment, that would be great. That that would be quite challenging, but the uses are pretty extensive. We use it in additive manufacturing for rocket engines right now.
And what is the maximum production of feedstocks in the form of iron powder that has to be achieved per day, per month, per year?
And real quick, that's the same thing we discussed earlier. You could have a demonstration system, so there's no, a very small production. But if you want to target a use case where you're producing metal rails for a lunar train, then you're going to need a lot of it. It depends on your use case, but your system should be scalable so that if you do a demo, you should have a plan on how you could scale that system up to be to provide a good return on investment.
Right. So the short answer is it's up to you.
That's always our short answer. All right, let's move on to number 11. Are there limitations for the equipment installation and construction on the lunar environment?
Yeah, you can read. I don't think there's any planetary protection stuff you got to worry about, but the insulation and construction, just make sure it's safe for for the infrastructure, and it won't hurt crew and the standard stuff. There's all kinds of safety requirements on one of the links we've got in the charts here. So and then also on the requirements, like I said, large power is going to drive up cost. Large mass is going to drive up cost. You're looking to develop a space, systems for space. So consider these things. And if you need maintenance time for astronauts in spacesuits, that's really tough because it's hazardous. Any spacewalk is going to be hazardous and it's going to be expensive. So try to have low maintenance requirements on your system, or let it be able to be operated by a general purpose robot that does other things.
Our next question is related to location. Teams are wondering, do they need to assume a south pole of the moon as the location and where Artemis Space Camp might be, or can they go elsewhere on the moon?
Yeah, the short answer is we're not dictating any location on the moon. I know the ore concentrations differ in different places, but like I said, Artemis is always a good choice because that's what we're targeting primarily to get water, which has your oxygen, hydrogen, which is so important to space travel and long-term exploration. But you can pick anywhere. I mean, I did say that the figure of merit for where we place a base camp is going to be pretty low for the ore concentration, since it's not going to be a priority. Priority is going to be science. Priority is going to be whether there's water and whether it's safe. And so the ore concentrations are going to get pretty low priority. So I'd try to be realistic about that.
And again, just explain what you decide to use.
Justify those assumptions. All right. So the next question is also related to where on the surface of the moon that the metal fabrication process is expected to be implemented. But even more specifically, what kind of natural environment can they expect in that area?
Yeah, you can look up at the lunar poles where the Artemis Base Camp is. You can look that up on the temperature ranges. You can look up, there's information about the radiation environment. There's information about the lunar dust environment. There's a lot of things we don't know about at the lunar poles as far as, the fluffiness of the regolith, or, and other things like that. So It depends on your use case, and if you're on the equatorial area, the high temperature extremes are higher. It's all there if you want to look it up, but again, it depends on your use case.
What is the expected content of metallic materials in bulk regolith at the location of the project on the moon?
Like I said, it depends on where you're going, and try to be optimistic about it. There's a lot of white papers, and I think we've got a link from the USGS on minerals on the lunar surface. They just released a very complete one, and it's in a later question. But yeah,
Is
you'll
it
have to
within,
make a good assumption.
is it within the bounds of the challenge to consider the usage of small amounts of other lunar materials besides ilmenite and anorthite?
I think Karen answered that absolutely. There's other minerals on the lunar surface. The reason we just use ilmenite as an example because it has iron, titanium, and oxygen. So it's one of the ones that's most looked at as a potential ISRU ore. So and it is fairly high concentrations, and we do have it on Earth. And so one of the cool things is if you want to actually demonstrate something, you can get ilmenite from several different companies and grind it up or do whatever you want with it and show that you can do something with it. And so if you got ores that are very rare on Earth, it'll be a little harder to do that demonstration.
Good point. Would the production or isolation of silicon from anorthite as a byproduct be of any interest to NASA?
Yeah, just real quick, any dual use system has value, but you've got to weigh it against the additional complexities and risks and things like that. Silicon is, it's mentioned it could have some uses for heat resistant surfaces, landing pads, and a few other things that later on, as we develop the lunar infrastructure, maybe they could build solar arrays or something like that. But right now, it's, I'd say it's got a fairly low value until some of this infrastructure is placed. But like I said, any dual use technology is valuable, has added value.
But I do like the comment that says that even though that dual use is valuable, don't let it detract from the main focus of this challenge, which is definitely metals focused. So I want to hit that in there.
Yep.
Question number 17. Will considering extraction or forming processes for multiple metals give a team an advantage over teams that only considered one metal?
Yeah, that's a very similar multi-use technologies. If you can do the same thing, two different things, two different metals with one system, then that's great. But it may add complexity, maintenance requirements, and other things that have to be weighed very carefully against the added value.
And when we review these proposals, we're going to look at the entire proposal, and so it's the approach, and so any one factor is probably not going to be something that pushes you over the edge. It's looking at the aggregate, the whole of what you propose. So keep that in mind.
And also along the lines of what is preferred, will the creation of novel or versatile products be preferred? For instance, if a proposal had a mechanism to make both aluminum metal products and to produce aluminum oxide fuel.
Yeah, that's the same answer on the other one, but the word in here that I'm going to pull is novel, and like I'll say that the novelness of the solution, if we haven't thought about it, and then guys can show it's credible, then we're going to look at it a lot closer because a lot of people have been thinking about some of this stuff, but if you come up with an out of the box idea that's highly novel, we just had one on the challenge before last where we had this cryogenic dust removal concept that nobody at NASA I think had thought about, and then and they ended up winning. So yeah, highly innovative solutions, if they sound credible, are very important, but not
And
not critical.
what is the expected useful service life for lunar? Oh, go back. to the slide. We're done. There you go. What is the expectable useful service life for lunar forge devices and components?
Oh yeah, just that's an easy one. Long enough to be cost effective or achieve a return on investment, or if you're a demo to verify that it's, that you can demonstrate that you can operate in the lunar environment. So yeah, it's up to you guys. But a return on investment, we don't want to do anything if we can do it cheaper by bringing the material from Earth. And so if you got to bring a system up to the lunar surface and it only lasts a couple days, I don't know how you're going to get to show that it's cost effective.
The next question is something we've touched on a little bit. This team asks, how must ideas which only work in the environment on the moon be demonstrated, such as processes that require the low atmospheric pressure and the gravity of the moon?
And if I can jump in on this one, I would say do your best. You've always got, so trying to replicate the gravity. If you need that gravity, then you're going to have to explain how the differences between what your experiments on the ground might, how the Earth gravity impacts or affects your results. Also consider that modeling is there are computational solutions that can be used in combination with, designing a careful experiment and then just using that to explain, here's what I would realistically expect to see in a environment that I can't replicate on the moon, on Earth. I've also seen people put their equipment upside down, right? So think about other ways that you can try something out to see if you can change the gravity vector with what we have here.
And Karen's right. We ask you to do verification. Verification is either test, demonstration, or analysis, which could be computational fluid dynamics or something else. And so, you can verify it in many ways, but you do have to demonstrate some hardware of some sort. You can do analysis for some of the environments, but others you'll probably want to demonstrate something.
So the next couple questions focus on some clarifications of things in the guidelines. In one of the main points in the guidelines, it states, where complex infrastructure is not available. What is the exact definition of that statement?
Yeah, anything in early lunar infrastructure is going to be very limited. You're not going to have too much in the way of spare parts, repair facilities, and maintenance and things. So, yeah, think about what would likely be there. We talked about this. Make your assumptions, but there's not going to, depending on the time frame that your use case targets. If it's 2035, we may have some kilopower systems up there giving a few tens of kilowatts of power, but you're not going to have unlimited power. You're going to have limited robotics, and spacewalks will still be limited to develop your things. We probably won't have roads and trains, and so think about what's reasonable for the time frame your use case is targeting.
And in the required capability statement, what is meant by a working system or subsystem?
Yeah, we talked a little bit. We already talked about your system of interest and what do we mean by working. It has to do something. And so this is not an ideation challenge like a lot of challenges out there where you come up with a proposal and you do some analysis. You have to have a working hardware. And so whatever scope you have on that, it could be a very small scope, but you've got to have some hardware that does something of value.
And is there a resource for design specifications? And if not, where is a good reference point for some of that specific information?
Yeah, we deferred on that a little bit, and just there's all kinds of NASA standards. We got a link to the NASA standards documents that has safety standards and recommendations for spacecraft, and it's a pretty lengthy list. And so pipe diameter is going to depend on your use case and what you want to use it for. You think about if you're the visionary entrepreneur that wants to make a ore train on the lunar surface to bring ore from the beneficiation plant to the product, your forge or whatever, and then you can sell that. Think about what you're going to need for that. How big are your rails going to be? How big are your ore cars going to be? You're the guys coming up with that. So you're asking us a question that's going to define your use case. And so once you have your use case, then you figure this out.
The next question is also asking about resources and wondering if there's any preliminary information that will be provided to the teams. And I'm just going to go ahead and answer this one because we actually have a really robust resource section on the website that has a lot of information that will be helpful to you. We've given a new link here, and that will be added to our website, as well as at the end of this presentation, we've got a couple other things to share and discuss with you. So definitely check out the resources page, the link that's here, and you'll have more information at your fingertips than you can imagine. So then getting back to the next question, there's some constraint questions. What are the energy, time, temperature, volume, and pressure constraints of the operation?
I think we've already discussed a lot of that. And like I said, think about your Shark Tank pitch. You're going to be describing your use case and showing that you can make something, because we want to fund you. If you're building something of value, we want to be able to fund you on that. And so your energy, time, temperature, volume, and your constraints are all going to be about your return on investment. So if you're using lots of energy, think about how you're going to get that energy. If you want to do that, you're going to probably have to buy that energy from somebody else. And so how is that going to affect your return on investment on this Shark Tank type pitch that you're putting together? I don't know if I covered that one quite well. I will let Karen, if you want to add in.
Yeah, so time, if you've ever watched the astronauts moving around on the International Space Station, time is very slow in space. Things move slowly. So I would not consider time a constraint. Pressure, you're operating in a vacuum, so that's something to consider. If you need a if you need a pressurized environment, you'll have to provide that and plan for it. Likewise, volume, the constraint on the volume is going to be your launch size, the size of your launch vehicle. And if you're consuming most of a launch vehicle, you're probably thinking bigger than might be realistic. So a lot of it again is try to be realistic, and frame your own constraints and just explain what they are, right? You're going to make some assumptions. You're going to say, okay, I assume I'm going to have 1 kilowatt of power available, and that's what I'm going to do with it. And so we don't have those numbers. If it hits it out of the park and solves a huge problem, we'll find a way to get the power that we need.
Fair enough. All right, the next question asks, is there a maximum electrical energy use value for metal extraction or forming processes?
Yeah, if you guys, if you want to be realistic, look at some of the systems that are being developed. Game Changing is one of our projects is called Kilopower, and the target on the Kilopower, which are nuclear thermal reactors, are under 10 kilowatts. And so if you have more than one of those, of course, you could get up maybe into the tens of kilowatts, but eventually as the lunar infrastructure grows, you might get up into hundreds. But thinking about, your energy use is so key. Instead of, if you can substitute electrical power for heating through a solar furnace or something like that, it would be valuable. But I know heating metals and doing a lot of these things is very energy intensive. So, one of your jobs might be to produce some low power methods of refining metals, because it's such a limiting resource. Even though you're on the lunar surface up at the poles, that sun is coming in a very low inclination, and you have to have solar arrays on towers a lot of times to get that. And lunar night, even at the poles, you still get long periods of total darkness where the sun is below the horizon, and so you have to run everything on batteries, or if you have some nuclear thermal power system. So yeah, you try to be reasonable. Like I said, 10s of kilowatts. I wouldn't go over 100 kilowatts, but it may be in the 2040 time frame you'll have the megawatts. But yeah, try to be reasonable about it, and look up kilopower, look up vertical solar arrays and things like that to give you an idea.
Some other things to think about is, do you need electricity at all? Can you use concentrated sunlight? Right? Is there a and do you need that electricity as a continuous stream of electricity, or will you need bursts? Is it something that you can charge a bank of capacitors over a long period of time and then get that burst of high high maximum power for a short duration? And so it's not just the max power, but it's the
Yeah.
the availability of power over time is something that you need to consider as well.
Yeah, we've got a lot of challenges right now just trying to survive the lunar night, because it's so cold, and to try to keep batteries, things alive during that long lunar night is a real challenge.
And you can also pick a place that doesn't have long lunar nights.
Good point. Our last technical question that we received in advance is, what are the safety requirements for the projects?
Yeah, like I said, all the teams have to come up with a safety plan. If you're working with high temperature systems, additive manufacturing systems often have lasers. You have mechanical systems and others. You got to write a safety plan. This is for your safety, but now if the question is targeted for the lunar operations, again, there's a lot of safety requirements out there for crewed and uncrewed missions, and so the crewed missions are pretty stringent. You look at things like sharp corners, and a sharp corner will cut a spacesuit, and so there's a lot of safety things. But just go look at the standards, and if it doesn't answer your question, you can do some follow-up questions to NIA or your subject matter experts.
But recognize again that that safety plan is not a safety plan for the operations on the moon. The safety plan is, how are you going to safely conduct your experiments in your lab, right, Kevin?
Yeah, that's I sort of gave two answers because I wasn't really sure which was targeted on this question.
Okay, well, that concludes the technical questions that we received in advance. We did have a few programmatic ones, and we're going to kind of fly through those, and then we will open it up. We'll answer some of the questions that have been dropped into the chat, and then we'll allow any other questions that have come in. So Janice, if you don't mind turning your microphone on and asking that first programmatic question.
Advance. Is variability in the finalist teams a significant factor in evaluation? For example, if there are 3 proposals that focus on product testing, would the judges be likely to choose just one and let the other finalists represent other components of the pipeline?
So variability is often a factor in selection of the finalist teams, because the judges really are truly interested in supporting a variety of different types of projects. Again, we also said, we're looking for some smaller scope projects and some larger scope projects. However, each proposal is ultimately going to be evaluated on its own against the established proposal evaluation criteria. So there's a link here, there's a link in the guidelines to that proposal evaluation criteria. you'll know exactly the things that you're being evaluated on. So make sure that you address them in your proposals and everybody has a fair and even playing field.
Great. How will dissimilar ideas and processes be judged against one another, such as an idea solely based on extraction compared to an idea solely based on reworking refined materials?
Again, each proposal is going to be evaluated on its own against the established criteria. So the criteria was developed in terms of looking at how the proposed concept brings value to NASA. And they can bring value to NASA in a number of different ways. So the established criteria is kind of that fair way of establishing or of evaluating all different types of proposals.
Should teams conduct preliminary research in a lab environment before submitting a proposal, or will most research be scientific paper-based without actual lab work?
It's up to each team. Doing that preliminary lab research and work is not a requirement at the time of the proposal. But if you have the ability to do it and you want to do it and it will make your proposal strong, then more power to you. Go for it. Remember, your proposal is your team selling your idea to the judges. So make it as good as it can be. And if you've got that capability, go for it, but it's not required.
Great. The max student group is 25 students. Would otherwise unaffiliated students that help with one task be considered part of this total? For example, if a lab assistant helps the team in machining a single part, would they be considered one of the students?
So we really think of team members as the people who are actively contributing to the project in a fairly significant way, generally in a regular or an ongoing manner. So in the example that was given here with the lab assistant, we would not consider them a member of the team. They're just somebody who kind of provided a simple service to the team.
All right. Will additional teammates be allowed to join as the research continues, both before the proposal and after finalists are chosen to build their idea?
Yes, we know that this particular challenge spans different academic years. We know some students will probably be graduating in May, and then you'll have some new students that might be coming in the fall. And so we definitely anticipate changes. We just ask that anybody who comes in and is really supporting the team in a significant way, you make sure to give them credit in that final paper, especially if you're accepted as a finalist and will be submitting that final paper. We want to know everybody who contributed to that because they will be published on our website, and we want to make sure that they can show and demonstrate that they were a part of that and have a publication there as well. So, and that kind of answers one of the questions that came into the chat. You know, if a student is planning on graduating in May, they can still participate. And actually, some of our teams in the past have found a way to continue to keep them working with the project, either as hiring them as consultants for a few hours a week of work after they graduate, or bringing them on as part-time researchers at the university. And some just came on then as mentors and consultants to the project after they graduated from school. So you can definitely be flexible in the way that you want to structure that, and know that, you know, some participants may only be able to participate up until they graduate, or for one semester. They may have a co-op another semester and they're kind of off doing work with that. So we are very flexible with how you want to bring people in and out of your particular project.
All right. What is the distinction between a PhD student who is considered a mentor and one who is an official part of the 25-person team? What level of contribution toward the project separates one from the other?
So we don't really consider level of contribution as a factor so much in this scenario. We're really looking more at their enrollment as a student. So even if they're enrolled as a PhD student, we still consider them a student.
Okay. Does space in the budget have to be allocated for students to attend the Big Idea Challenge Forum? To reduce project costs, can it be put upon the individual students to cover the costs of attending?
So the short answer is yes and no. We absolutely need to have at least your minimum number of folks included with travel costs to the Big Idea Forum in the budget. And we do that to ensure that those minimum of 2 people can be at the forum and can present your research on your behalf. So that's why we require that. It can be pretty expensive to come to the forum, with registration fees being $500 or $550 a piece. And then you add lodging and flights on top of that. And we don't want anybody to get to the point of it's forum time and we haven't raised enough money to go because you didn't plan for it in your budget. So we do require it to be in your budget. If you have others that want to attend on top of that and you don't want to include them in the budget, that's fine. But it's at your own risk, and we want to make sure that you're aware of that. So there was another question that came up in the chat asking whether or not there could be additional partnerships or things like that. We absolutely encourage partnerships. We encourage fundraising. You are welcome to do any and all additional fundraising on top of your proposed budget to NASA. And in fact, we've actually had proposals in the past that have included money that they've already raised toward their project, which was awesome for us to see, obvious, and only served to strengthen their proposal. It's not required that you do fundraising, but if you want to, all the more power to you, and it is very well received in the evaluation of each of the different proposed projects. So we've had students that have reached out to industry to get things like in-kind use of testing facilities, or in-kind material donations, even cash awards to the team to continue working on this research. So all of that is acceptable. You can reach out to industry for mentorship. There's lots of different ways that you can get other folks involved, and you can do all the fundraising you want.
All right. What type of content would NASA like to see in the video submission?
It is 100% up to you. The only reason we offer the video is because oftentimes teams can demonstrate or show things using animation or just talking versus writing it down. Sometimes helps them to explain their concept a little bit better. So it's just one tool for you in your toolbox of trying to sell your project to the judges. So use it in whatever way will help augment your proposal in the best possible way. We're not looking for anything specific.
All right. Is there a certain dimension ratio that is preferred for the video, like 4:3 or 16:9?
We like the widescreen aspect ratio, the 16:9.
Can we use any image NASA has created, or only the images provided for the 2023 Big Idea Challenge?
Any image that NASA has created is open for public use at any point in time. And anything that we've created for the Big Idea Challenge, you're also welcome to use. We've included a link here to NASA's image library. It's a searchable library of images. Feel free to use it. Just make sure that you don't use any music or other images outside of this that are copyrighted.
Should the file be of a certain size?
The PDF proposal file cannot exceed 90 megabytes. And because the video file should be coming to us as a YouTube URL link, size shouldn't be a factor on that particular file.
Will there be a NASA mentor working or serving as a connection between universities and NASA? Similarly, is there a NASA contact that teams can reach out to if additional questions regarding the challenge arise?
So NASA does not provide a mentor for the university teams, but teams are allowed to reach out to the Big Idea program team, and our staff will get a response for any questions. I think I mentioned at the beginning that we will respond back to you directly and also post that question and its response on the FAQs page so everyone has access to it. So we definitely encourage you guys to check out the FAQs page frequently for updates.
All right. What kind of opportunities would be available for feedback once funding has been awarded?
Every single person who submits a proposal, or every single team, will receive written feedback on their proposal, and that's regardless of whether or not they are awarded or not. The teams that are awarded and selected as finalists, the week after you're selected, we have some time set up with Kevin and Karen to give you some verbal feedback during over a phone call, and it'll allow them to kind of guide you in the direction of the things that they really liked about your proposal and maybe steer you away from things that they aren't as interested in, so they can kind of talk to you a little bit about scope there. and allow you to ask any additional questions that you might have of them at that time. And then for the finalists, there's another midpoint project review where you submit a 3 to 5 page paper documenting the success and whether or not you're on target to do what you actually said you were going to do in your proposal. And at that point, the judges review that midpoint project review and provide some feedback, written feedback to you again at that point. And those are really your two biggest areas of feedback through the challenge.
If we have later questions, is there someone we can contact to ask those?
Absolutely. You will email us at bigidea@nianet.org. And again, we'll get that answer to you.
Okay, that concludes our programmatic questions.
All right, well, let's go ahead then and start with some of the questions that came through in the chat earlier on. It looks like the first question that we got, Robin, are you in the position to have the ability to open up that chat and go back to the front and ask those questions?
Sure. So much of these processes need to be vetted in an environment that cannot be tested on Earth, that need more than 10 to 9 torr. How will projects dedicated to assessing this basic science understanding be scored compared to folks wanting to do end-to-end concepts?
Yeah, if I read that, it sounds like they're looking at maybe developing some types of instruments that they can't test unless they get in a real lunar environment. And my answer is maybe you can improve the state of the art on testing or get to some level and then use analysis or model the data points that you're able to get to extrapolate, the answer further. If you can convince people that you've got a new measurement capability that can detect things, but you can't fully test it on, in Earth-based environments where you can't get down to certain levels of vacuum, it would be valuable. It would have value there that would want us to go and say, hey, well, maybe you can provide confidence, by modeling it through extrapolation and get higher resolution testing data points than is currently available, and it would convince us to say, hey, if you can show that this has potential, we could potentially do a lunar demonstration mission or something along those lines that would be good for prospecting. I think that's what you're looking at is some type of way to prospect for metal concentrations in the minerals. So that may have value. I don't know if that answered the question. I saw Don Barker has a lot of questions, has a lot of comments and questions. So
Thank
Don,
you.
can you hear me? Did you want me to talk more on that or no?
Or did you want to clarify anything, Don?
Okay, yeah, kind of that 10 to the minus 9 torr is kind of our limit for functional usage on the Earth in most testing conditions, unless you get a lot of money and a lucky time on a other type of chamber. But I was not thinking so much as a sensor as so much testing. For example, lunar surface sintering. We cannot really vet that process on Earth. Because you are working through the lunar vacuum surface environment. There's other things that would be in this line of thought with regards to resource extraction also. So it's just a limiting factor, and I just wanted to kind of point that out. And I didn't know if there was, so we have to do a certain amount of basic science here that takes us up to 10 to the minus 8, 9 torr. And then we don't know at that point, and we won't know without, actual surface research.
I don't know if I can add anything to what I said based on that. I don't know, Karen, you have any thoughts?
I think my suggestion would be you start at the vacuum levels, that you can have access to, and then that's where, you know, some of the computational, perhaps ends up filling the gap between what's achievable you know, in the lab and, what we would have to try on the moon.
Thank you. So we have another question. The NOI asked for a notation of any expected or established partnerships. Can new partnerships not listed there, possibly due to a later securement, be used, or would that violate the rules?
I can answer that question. You can add partnerships at any point in time along the way.
Perfect.
Easy one.
Will
I don't know,
existing,
maybe a general thing on Stacy, the NOI doesn't limit anything in your proposal, does it?
Nope, they're non-binding. That was just a
Yep.
quick idea for us to make sure that we had enough reviewers for your proposals and to see if anybody had proposed something that seemed really off course that we could kind of help direct you back on course. But you are welcome to make any changes from the time you submitted your NOI to the time you submit your proposal. We fully anticipate there'll be changes.
all right, we have a few more. Will existing technologies at a facility need to be included in the budget plan?
I would say that's up to you. You need to
Okay.
tell us what testing facilities you need and if there's a cost associated with using them.
Is there a maximum number of faculty or students who can attend the Big Idea Forum?
The answer to that question is yes. We are going to limit it to 25 per team. So your maximum number of students that are on that team.
And our team has 2 universities in different states. Can the Space Grant Consortium of the primary university state support the other university team in a different state?
That is a question that we are going to have to get back with you on. Let's see, who was the one who asked that particular question?
It was Rue,
Okay, if
RYU.
if you don't mind, could you send me an email to the Big Idea email address with specific information on which states that you're in? And the reason I say that is because every single state consortium has different rules on subawards and how they work together or independently. And so that's not something I can address as a whole for all 50 states. We need a little bit more information on your specific situation. But we'll try to figure that out for you.
Okay, thank you.
Are there any recommended sources for synthetic lunar regolith available for purchase?
I'll just throw in, I talked to several of the vendors for the lunar regolith, but I think we shouldn't be recommending specific ones because there's several out there that would, you know, that's not ours. But if you go look in the resources, there's a listing and several of the suppliers are listed in that that reference that we have for basically simulant providers. And so your best bet is just to talk to the individual ones and based on which, I can't say or now because I saw that or is not quite right, but whatever mineral that you're looking for, ask them because some can get you higher fidelity stuff and other ones can get you bulk material at lower costs. And so it's going to be up to you on which one you want to reach out to. But it may be that you get lower fidelity to test something, and then for your demonstration, you'll get the higher fidelity stuff. So it all depends on what your test plan is.
Okay, thank you. Is the
This is
challenge,
Don. Can I make one comment there that might help everyone? I would suggest that anybody interested in talking simulants or using them, contact the Ares Lunar Simulant Lab at JSC. They have an external webpage. They can provide consulting purposes. That's their whole job. Simulants are a world amongst themselves. So I suggest you start there.
all right, and last question from the chat. Is the challenge just focused on metals or can minerals be used in manufacturing processes proposed?
Yeah, we'd like you to develop some type of metal product, that I'm trying to understand on can minerals be used? Um, are you saying that can you use ilmenite, for instance, to make a product? I don't know. I think we're pretty much focused on extracting some type of metal or metal
So,
alloy or
so
creating
yeah, so what
alloys in a product. Go ahead.
what's being referred to here, I think, is like silicates and like silicon in particular, rather than focusing on, for instance, aluminum, titanium.
I didn't quite catch that.
Oh, sorry. I was just referring to, like, for instance, using silicon rather than focusing on aluminum, titanium, just looking at slightly tangential parts of a lunar base that you might want to manufacture, for instance, photovoltaics.
Okay.
Yeah, and I think that the answer is we had a similar question earlier. And so we're primarily looking at metals if there are spin-offs or byproducts of that metal refinement that gives other usable products that is useful to note, that the byproducts, are useful products, but the focus is really on the metals.
Okay, got it. Thank you so much.
And unfortunately, we are coming to the end of our allotted time for this particular Q&A session. There are a few quick things that I wanted to share with you before you pop off that will be useful to you. Jan, if you don't mind flipping to the next slide. Just a reminder that our next deadline coming up is our proposal deadline, January 24th. We do not accept late proposals, so do not even ask. That is our deadline, midnight at our 11:59 p.m. Eastern time. The form shuts down, so make sure that you plan accordingly. And there's just some notes here about tips for the proposal. Again, we wanted to reiterate the fact that your proposal, kind of the level of maturation, is that it should be at the convincing level. Include enough information in your proposal to really convince the judges that what you've proposed is credible, it's valuable, and provide confidence that your team can successfully implement the work that you propose. We also want to make sure, again, that you look closely at that proposal evaluation criteria and ensure that what is included in your proposal addresses each of those aspects. This does have a very complicated two-phase budget requirement, and we know that up front, and I apologize for that. It is a result of the way that the funding has come into us and how it has to go out from NASA. So it's kind of outside of our control, but we do ask you to carefully review the budget section and make sure that the budget that you submit to us follows that two-phase budget instructions that we've provided. We've given you a template to use and a detailed document to go along with what we're looking for in all aspects of the budget. If you have any questions, don't hesitate to ask us. I would say last year, 90% of the questions that I fielded were related to the budget. And so you're not the only one that probably has those questions. So don't hesitate to reach out and we'll help you through that. I do want to also state that we understand that the proposal process is a bit intensive. There are a lot of things that you have to include, some different forms, some different letters of support. We ask that your budget be reviewed by your Office of Sponsored Research, and that the second phase of the budget, which includes space grant funding, also has to be reviewed and approved by your space grant director at your state consortium. So we know there's a lot of things that you've got to include in this. So we encourage you to really plan early, have your proposal done early and ahead of time so that all of those folks that have to review and sign off and submit a letter saying that they have reviewed and approved your proposal, they have time to do that as well. We also realize that with the proposals due in January, some of you are just coming back from break at that time. And so that has been something that has been a struggle for some universities. We are aware of it. We just didn't know how to get around it in order to give you enough time to build what you're going to build if you are selected as a finalist. So just plan early, make sure they've got the information they need ahead of time. And one thing we've done new this year is to create a proposal checklist. And that proposal checklist is something that you need to make sure you've got every single thing on that list checked off and included in your proposal when you submit it to us. NASA is spending a significant amount of money and giving you a lot of time compared to some of the other challenges to really be able to do something wonderful to help advance the state of the art in some of these areas and to truly demonstrate and test your concepts. So that's what we're looking for in the proposal. If you could flip to the next slide, Jan. So earlier in the chat, Don brought up LSIC, or the Lunar Surface Innovation Consortium. And this is a consortium that's focusing on 6 capability areas to help support a colony on the moon. And one of them right there up at the top is focused on in situ resource utilization. And so they are really looking to collaborate with universities. They're looking to collaborate with other agencies and corporations. And so we encourage you to join the Lunar Surface Innovation Consortium. I've got the first link takes you kind of their homepage. You can look around and see what kinds of things that they're up to. And specifically, if you want to sign up for the consortium, is that second link there. You can find that from their homepage as well. But we do encourage you to join. It is free to join. There's lots of networking opportunities. There's lots of exposure to experts. There is, they do webinars all the time and record them. So we encourage you to utilize that as a resource. And the next slide shows you another resource that we encourage you to take a peek at. NASA has just recently developed this website, the TechPort website, which really talks about their framework for how they are moving forward and thinking about the development of technology. And as you can see here, under the middle bottom, the live section, one of the things that they're focusing on is in situ resource utilization. And so there are some videos there, there's some PDFs, there's presentations, and a lot more resources for you specifically related to Lunar ISRU and the strategic direction that NASA is going into. So we invite you to take a peek at those. And then finally, the last slide. Just in case you have not found those challenge guidelines on the website yet, you can take a quick snapshot of this QR code here and get those sent right to your mobile device. And again, a link to the email address where you can send all future questions to. We'll definitely post this recording and a transcript, a written transcript of the questions and answers on the FAQ page. Keep checking it back frequently throughout the year. And let us know if you have any more questions. We'll make sure everybody gets access to them. Karen, Kevin, thank you so much for your time today. And Robin and Janice for helping to pull all of this together. And for each of you for your amazing questions. And we can't wait to see your proposals. Thank you, guys.